Hello and a warm welcome to my YouTube channel. We're going to have a look at some iGCSE how to answer paper 1 style questions. Okay, 14. The diagram shows the readings on a thermometer before and after a reaction. So the first thing to note is the big number is at the top. So this one is going to be 13 point something because the next one up is 14. And this one's going to be 34 point something because the next one up is 35. So if it says 14 point something, you can immediately discount C and D. This one, so these two are the same, so we're all giggles. Haha, those are the same, so that must be correct, and just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, so that's on 5, so we are happy. After the reaction, it's at 34 point 1, 2, 3, 4, 5. That's 34.1, isn't it? 35.9 will be somewhere is A. 15. This represents a lithium atom. It's worth getting funky on this one. The black, we should do the colour, couldn't we? We've got some solid black ones here, some empty black ones, and a circle with a cross. Now we're not sure whether this is protons and this is neutrons. It doesn't give you that information. But we do know that the protons and the neutrons, they live in the nucleus, in the centre of the atom. The things that go around the outside, around the outside, around the outside, Buffalo Girls go around the outside, is the electron. These are electrons in the first shell, second shell, third shell, fourth shell. The maximum in the first shell is 2. In the second shell is 8. In the third shell is 8. In the fourth shell is 18. And that's where iGCSE stops. Because that's the best fit model. It's not so accurate to see what model we could use. The answer to the question, what particle is the X? The answer is the electron. Okay, this is a nice plastics question. This is addition polymerization. How do we know it's addition polymerization? We know because we begin, or we start with a double bond. Addition polymerization, you must have a double bond. You cannot polymerize a single bond. So that means that's wrong and that's wrong. We're after polyethene, ethene, so Midgley eats pink biscuits. You cannot have methane because an alkene has a carbon-carbon double bond. So the first one we can make is this one, which is ethene. Propene would be the next one. 1, 2, 3, put the double bond in, count to 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There's propene. And just for completeness, 1, 2, 3, 4 carbons for butene. Put the double bond in. It doesn't matter if we put it there or if we put it here or if we put it here. In fact, the last two are exactly the same. Just for completeness, we'll put it there. Count to 4. Did you get that? See, well done, you spotted it. 1, 2, 3, 4. Put the hydrogen into the molecule. There is butene. That's just an aside. The question is about polyethene. So the double bond is unsaturated, and the polymer is saturated. Now this is still unsaturated, so it cannot be A. So we've ruled out A, C, and D. The answer is indeed B. Okay, 3 minerals containing iron are listed. That's cute. What is the total number of different elements contained in all 3 minerals? So there's iron in the first one, and oxygen and hydrogen. There's the iron, there's the oxygen, there's the hydrogen. In this one there's iron and oxygen, we've already got that one. In this one there's iron, oxygen, and carbon. So there are 4. So the answer is B. 17, the diagram shows the electrolysis of a compound. It doesn't tell us what compound it is, but it will give us some clues in a second. When the switch is closed, for this to close, that will complete the circuit, allow electrons to flow. Remember that the big one, that one, you can break in half and form it into a plus. And indeed, that is the positive electrode, which is the anode, because negative. Or the small one here is a minus sign, which is the cathode. When the switch is closed, the solution around electrode P, so here, turns orange. Do we have an orange? We must have an orange. There's an orange. P goes orange. Beautiful. Because a halogen is formed. This is knowledge of your halogens, isn't it? So there's fluorine, chlorine, bromine, and iodine. Halogens. Fluorine's kind of a yellow, I want to do a yellow pen then, a yellow gas. Actually looks more green to me, but I'm slightly colourblind. Chlorine is a green gas. Bromine is an orange liquid stroke gas. It's a very, it comes from bromus toxic stench. And then iodine. Iodine is not the stuff you get in bottles and squirt onto leaves to turn it blue, to turn positive to the starch. Iodine is a silvery black metal. Well, silvery black semi-metal with the world's most wonderful colour, purple vapour. Okay, so they're asking you, do you remember your halogens? So at electrode P, that's the positive electrode, which is here. There, electrode P is the positive electrode. Thank you, give my pen back. Here, so opposites attract. So Br minus is going to generate Br2. This is Br2, this is bromine. Now I need to balance that equation. There are two bromines there, so I need to have two bromines here. And there are two negative charges here, so I need to have two negative charges, two electrons on the right-hand side. Opposites attract. Bromine, bromide, has gone to the positive anode. So the positive electrode is called the anode. So it's not that one, and it's not that one, because they say cathode. And the halogen is, well, the halogen is orange, which is our bromine. So it's not that one. The answer is A. Which statement about chemical reactions is correct? So this is talking about exothermic reactions. Start again. Exothermic reactions. We have reactants and products. Here we have energy, here we have time, and we're talking about endothermic. So this is exo, this is endo, and now we have a different situation because our products have higher energy. Siri, thank you. What's it telling me? Endothermic reactions result in a temperature decrease. They do. Temperature goes down for endothermic, it takes energy in. So endo getting cold, so that looks good, but let's look at the rest. Endo results in a temperature increase, no, that's exo. Exothermic reactions always produce a large temperature rise. They don't always produce a large temperature rise, sometimes it's a small temperature rise, so that's incorrect. And exothermic reactions always produce a small temperature, no, it's just as silly as the last one. We were correct, the answer is A. 19, in a manned spacecraft, carbon dioxide is removed from the air by reacting with potassium hydroxide. So CO2 plus KOH. You should know that carbon dioxide is an acidic gas, and any group 1 hydroxide, metal hydroxide, this is going to be an alkaline, which is just a base in water with OH minus. So acid plus alkaline, acid plus alkaline is going to neutralize. B. 20. Which test will show that fertilizer contains nitrate ions? This is your qualitative tests. Okay. Do you need sodium hydroxide? Well, I hope so. It's in every one. Do you need aluminium metal? Yes, you do. So it's neither A nor B. When you add aluminium metal and sodium hydroxide, you reduce the nitrate to ammonium, which is an alkaline gas, so that will turn litmus blue, not red. The answer is C. 21. Which letter shows the position of a metal with a low melting point? You should know that all of these are the non-metals. Then kind of in here we get the semi-metals, so we can immediately discount C and D. It's neither of those. In this block here, these are the transition metals, so it's not B, so it's A. And we all know that group 1 have a low melting point. There's lithium, sodium, potassium, rubidium, cesium, francium is the group which is here. Low melting points, float on water, give nice exciting chemistry. 27. A green halogen gas. Remember which one was the green halogen gas? The green halogen gas is chlorine. It is bubbled through potassium iodide. So it's Cl2G going through potassium halide. Okay. Doesn't tell me which one. It does tell me it turns brown black. So fluorine was yellow, chlorine is green, bromine is orange. The only one that's left is iodine. I know astatine's underneath it, but no one ever mentions astatine. It's like the friend at a party that no one speaks to. So it's brown black, so it must be iodide. The most reactive displaces it. That's 2I minus and 2Cl minus. Okay, because all halogens are diatomic molecules. It's just a posh way of saying that there's always 2 atoms in one molecule of any halogen. Why? Because they share a pair of electrons in this bond. One shared pair of electrons is a single bond. The other way to write that is F to F, single bond, with 3 lone pairs of electrons. Okay, cool. So chlorine gas, so it's not bromine. That's incorrect. And with what is the halogen and what is the halide? If it's bromide, it would be orange, but it's brown black, so it's iodide. So it's not that. The answer is D. 23. Which row describes the general properties of non-metals, or the properties of non-metals? Melting points are low because non-metals tend to be gases, so it's not A. The density, if the density was high, it would most likely be a solid or a very compressed gas, I suppose. But they tend to have low density because their molecules are far apart. Non-metals are predominantly covalently bonded. There are certain situations where you could force them not to be, but we tend to avoid them at iGCSE. Covalents do not conduct electricity except covalents. We should say simple covalents do not conduct electricity. So no, it will not, which is correct. Yes, it will, which is incorrect. The answer is C. 24. Copper is extracted by heating copper oxide with substance Y. So copper oxide is CuO. We're going to add Y. We're going to make Cu plus YO. Yo! What is process X and what is substance Y? Well, X, the process is removing. So here, copper has oxygen. Here, copper has no oxygen. So it's removal of oxygen. The addition of oxygen is oxidation. The removal of oxygen is reduction. So that's wrong and that's wrong. Would limestone react with copper oxide? No, it would not. Calcium carbonate, which is limestone, here would sit there and look at you. No, will not react. There's some hair and some ears. Carbon will. Carbon's more reactive. Carbon is more reactive than copper, and you'd make carbon monoxide and maybe some carbon dioxide as well. So it's a reduction using carbon. The answer is C. 25. Which gas emitted from a car exhaust contributes to acid rain? You should know that water vapor is neutral. It's not that. You should know that nitrogen is neutral. It's a covalent molecule. It will not dissolve in water. If nitrogen dissolved in water, there'd be no nitrogen left in the air. Every time it rained, it would dissolve out, and it doesn't, so that's wrong. Carbon monoxide would come out of a car exhaust, as would nitrogen monoxide. Carbon monoxide may well form a weak acid called H2CO3, which is carbonic acid, which is mild acid rain, but it's not very strong. The strongest contributor to acid rain would be our nitrogen monoxide, which when we react with water will make HNO3, which is nitric acid, which dissolves buildings, destroys aquatic ecosystems, and kills fish. Okay, which graph shows the pH of soil changes when lime is added? So lime is calcium oxide, which is alkaline, and you add it to soil when the soil is acidic, because you want it to become neutral. So we need the soil to be acid. So this is acid, this is acid, this is acid, and this is acid. That doesn't help me. But when I add lime, this has the pH not changing. It's just a straight line, so it's not C. And this one has the pH getting even more acidic. Well, it won't, because lime is alkaline, so it's not A. This one, Buddha knows what's going on here. It becomes more acidic, then it becomes more alkaline. It's just nonsense. This one, it becomes gently past 7, which is neutral, around about 7.5, 8. It's slightly alkaline. The answer is D. 27, organic molecule, complete combustion produces CO2 and water. So it's CXHY, because it only produces CO2 and H2O. So there are no other atoms involved. It's some amount of carbon, some amount of hydrogen. It decolorizes bromine water. That means, could it be an alkane or an alkene? Well, it cannot be an alkane, because that does not decolorize bromine water, but an alkene does. So it's not ethane, it's not ethanol, it's not polythene. Where did that come from? It's ethene. Okay, which diagram? I'm ignoring the biology. Which diagram represents molecules of a compound? A compound has a specific ratio of elements to each other in the compound itself. These are two of the same, so it's not that one. These are two different types of molecule, so that's not that one. These are all the same type of molecule, it's not that one. These are a compound because it's two or more elements chemically bonded together, and they're all the same, so the answer is B. 15. How many atoms of metals and of non-metals are shown in the formula NaSV? SO. So sodium is 2. What type of element is sodium? It is a metal. Sulfur, there is 1. What type of element is sulfur? It's a non-metal. Oxygen, there are 4. What type of element is oxygen? It's a non-metal. So there are 5 non-metals here and 2 metals here. 2, 5, D. No. 16. Which row describes one lead ion, Pb2+, and in which electrode? So it's electrolysis, it's molten, we don't have the water problem. We know that we hate cats, want to kill cats, dead red cats. Cathode is negative, where reduction occurs. The anode is positive, where oxidation occurs. Put that in, positive oxidation. This is for an electrolytic cell. So Pb2+ is going to become lead. Lead is produced. How do we balance this up? Do we add 2 electrons here or 2 electrons here? Well, we add them on the left-hand side, don't we? Because now 2 plus minus 2, so the 2 plus from the ion, minus 2 from the electrons equals 0, and the 0 charge here. So the charge is balanced. They're all good to go. So lead has gained 2 electrons, oil rig, oxidation is loss, reduction is gain, and it is a cation, because it's got a positive charge. So it's not that, it's not that. The cation is attracted to the reduction at the cathode, so D. When sodium is added to water, it reacts violently and it melts. Which row describes the type of reaction and how the temperature of the water changes? It reacts violently, it melts, it kicks ass, I love it, it's exothermic. So it's not that and it's not that. And if it's exothermic, the temperature must increase. Exothermic increase, D, not decrease. 18. Marble reacts with dilute hydrochloric acid. 1 gram of powdered, so that's, this is often confused, so small particles equals a large surface area. Large particles equals a small surface area, because here you've got loads of little particles and all the little reactant particles can get in amongst it and in between, loads of reacting surface area. But here large particles, you've only got 1, so your reactants can only nibble away at the edges rather than get right in between in the middle. So powder will react faster because it has a greater surface area. Oh, there is B. 19. Aluminium reacts with iron oxide. It even gives me the equation. So we've got aluminium, we've got iron 3 oxide, so it's Fe2O3, going to iron plus aluminium oxide, which is Al2O3. So aluminium from here to here has gained oxygen, iron oxide from here to here has lost oxygen. So aluminium oxidizes, addition of oxygen, and iron oxide reduces, removal of oxygen. So does aluminium gain oxygen and iron lose oxygen? I quite like that one, because it does. Is aluminium reduced? No, it's oxidized, it's not that one. Aluminium oxide is oxidized, that's oxidized, no it's not, it's on the wrong side of the equation. And iron gains oxygen, no it loses oxygen, we said that here. So the answer was A. The pH of water changes when ammonia is bubbled into it. Ammonia is an alkaline gas, NH3 is alkaline. If it's alkaline, it has a pH greater than 7. So if we add ammonia to water, the pH will get higher, 7 to 14. This is our alkaline region of the pH scale. So the pH will increase, so it's not A or B. Because it gets more alkaline, the answer is D. 21. Copper 2 sulfate is made by adding an excess of solid copper oxide to this. So if it's already in here, this is due to sulfuric acid. So this is going to turn blue, isn't it? Because it's going to make copper sulfate, CuSO4. So how do we obtain copper sulfate crystals? So this liquid here, so first of all we're going to have to evaporate the water out to get the crystals, so it's not C and it's not D. Once we've evaporated the liquid, can we crystallize? It does crystallize, yes it does. Filter, there's nothing to filter because all the water has gone, so the answer must be A. 22. Which statements about group 1 is correct? Group 1 at the top, there's lithium, sodium, potassium, rubidium. Start again. Rubidium, cesium, francium. They're all soft. Which potassium is hard? No, it's not. Sodium is hard? No, it's not. So it could be potassium is soft. Which is more reactive? Well, reactivity increases down the group. So these kick ass. Don't put that in your exam. And these also react, but more gently. Is potassium less reactive than sodium? No, it's not, because potassium's here, reactivity increases down the group, so the answer is D. Because sodium is underneath lithium. What is used for argon? Argon is a noble gas. It's used in lamps. 24. Which element is used to extract some metals from their ores? Nitrogen? No, it's very unreactive. Don't forget, nitrogen has a triple bond, 2 lone pairs of electrons. Iron? No, that's used in the ammonia synthesis. NH2, making NH3, 2, 3, so it's not that one. Copper? No, we get copper by reduction with this element. The answer is carbon. 25. 4 solutions with UI and with anhydrous copper sulfate. Anhydrous copper sulfate is white, but if you add water, H2O, it becomes blue. Pure water, it would be neutral. Pure water is neutral, so it's neither A nor B, so that's good. And it would turn, we just said this, copper sulfate, anhydrous, blue. The answer is C. Why do farmers add lime to soil? Lime, again, is CaO, not a juicy fruits that you can make a drink with. It's going to increase the pH of the soil because it is alkaline, pH 7 to 14. The number will get bigger the more you add. Okay, that's the last couple of years of questions for chemistry for iGCSE 0654 Coordinated Science. Subscribe at the bottom. Good luck with your revision. Thank you very much for listening. Have a great